My name is Júlia Seixas. I'm coming from School of Science and Technology in the south bank of the city of Lisbon. I'm here today to speak to you about our research line, which is focused on energy and climate change. SENSE is the Center for Environmental Sustainability and Environmental Research. It's supporting 5 routes, let's say. One on water, sanitation and waste recovery, ecological economics, computation for sustainability, and green technologies. And the one I'm talking today is on energy and climate. So we strongly believe that we can achieve prosperity with a minimal resources use and with no emissions at all. And this is very required to achieve the climate aim supported by the Paris Agreement, that is to achieve 1.5 degrees Celsius above the global average temperature of the planet Earth before the Industrial Revolution. In order to do that, we have to look at the systems in an integrated way. We don't believe at all that in very incremental innovation or just looking for a specific part of any system, we can achieve this goal. So we dedicate our research on energy system transitions and also on climate change mitigation adaptation. And for that, we have developed different research aspects. A key one is one related to energy systems modeling tool that includes both simulation and optimization tools, looking at the energy system, as I said, as an integrated perspective, taking an holistic perspective of the problem. Another thing that we have dedicated lots of time and efforts is to assess and sometimes design new policies and instruments to tackle energy and climate issues. Most of them dedicated and focused on cities and urban areas. Also, more recently, we have dedicated some research on the issue on climate services for energy service. This means what the future scenarios on climate change will affect, for example, the power system of a country. And mostly also energy poverty and climate vulnerability has been one of the issues, and also a thing that has been an interface between the climate change and other dimension of sustainability is the use of resources for the carbon, for the energy transition, like the use of materials, the use of water and land. I will explain a little bit more later. So this is just to impress you, don't worry, but it's only to explain to you that we rely most of our research into fundamental tools, one more dedicated to technological assessment. This is an optimization model, and another tool is dedicated to general equilibrium models. So we are able to link the technological issues with the macroeconomic issues of a system, like the Portuguese system, for example. And this has been doing not closed in our environment in the university, but in connection with many stakeholders to whom we have developed visionings, perspectives for the future, for the future. So, based on this framework, we have been expanding this type of framework, and we have been applying in different perspectives. For example, we have developed a roadmap for Portugal to understand if the carbon capture and storage option could be a good option for Portugal, meaning good means cost-effective option for Portugal, in which sectors, in which time in the future, for example. Another example is the application of these tools at the city level, like this one at the city of Évora, and this one at the city of Almada, for example. And we have also been invited several times by different stakeholders in the country. And we are very happy to serve the public policy, and some private companies with our knowledge and our skills. For example, I will refer to the most recent one. Last year, we produced all the work behind the carbon neutrality roadmap. The Portuguese government has delivered the long-term strategy of the country in the United Nations regarding carbon neutrality and the compliance with the Paris Agreement aims. And the numbers that are there related to everything but forestry and agriculture, which really we do not work, comes from our group. Another very recent project is this one that is funded by EDP that asked us to assess how is the potential of hydrogen, because hydrogen these days are a very sexy option for Portugal and for Europe. And what does it mean for the Portuguese system? Is it competitive? In what sectors? At what costs? When? In the next 10 years or in 15 or when? So we used to develop using this type of approach, again, taking all the energy system, not only electricity, not only heat, for example, not only the mobility, but everything connected, because energy is a connected system in the country. So, for example, this is an illustration from the carbon neutrality that we produced. As I said, all these numbers and this trajectory, this is quite simple. At this moment, it's a quite simple graphic, but there is a huge work behind this graphic. So, as I said, except agriculture and forestry, and waste, all the other sectors we have managed, and also have managed the impact in terms of macroeconomic variables. Just to give you the impression, to prepare all of this, we have connected with many stakeholders for 100 organizations. And for example, this is an example of the impact and opinions and contributions that we receive from the stakeholders. And we have run more than 60 scenarios in order to accommodate all the sensibilities, in order to understand where is the common space of solution, taking into account the big companies, but also the very small companies, the NGOs, the different associations that characterize the Portuguese economy and the Portuguese society. So it's a very hard work. Another point that we are looking at this moment is the possibility, it's a technological avenue that we are exploring, is to analyze the possibility in Portugal together with other countries. This is an Horizon 2020 project for carbon capture, utilization and storage, for example, in a synergy with the cement industry. In terms of urban transitions, as I said, we apply this. We have developed work, for example, for the city of Everett, taking into account the different perspectives of the city from the technological point of view, based on a GIS, Geographic Information System, taking into account not only what's happening now, but what could be happen in the future in order to make this transition to the future, in order to get a sustainable energy system in this city. A specific research that I'm very passionate today is to link together in a city what is our basic resources, which is the energy, the water, and food. And we have discovered, I mean, the scientific community have discovered that if you take into account these three resources at the same time, we could innovate a lot. Maybe you are aware about the urban farming, and the urban farming have been developed in many solutions to provide food with less energy and with less carbon footprint from the outside of the city. Of course, the problem is quite complex, but at this moment we are developing a specific methodology, and we are applying this to the city of Cascais. We have also received quite a number of visitors from other countries, and for example, we have developed the research for the city of São Paulo and also the Great Cairo. At this moment, we are working in a very peculiar project that refers to the Alfama, our Alfama district in Lisbon, together with other 5 historic districts in Europe. And the point here is we are applying, because this is a project co-financing by Climate Kick. We are applying a particular methodology, very inspired in the philosophy of the Climate Kick, and we are testing in the place different solutions, not anymore with models, not anymore with our analysis as academia, but with some ideas that we bring from academia and working in the district with the stakeholders in the district. It has been a very, very challenge, I have to tell you. It's much more easier to write papers. So, but we believe, and following and supported by Climate Kick, that the academia and the researchers need to do this type of research with the persons in the locals. Okay, I'm seeing the clock. So, energy sector, what is meant by through climate adaptation, and this is a project that that are in the final part. So, climate services for energy, and in particular, the problem here we are tackled is the following. It's a very difficult one. For example, if you think. If you are aware, Portugal is very dependent of rainfall for hydro power, for example. And for the power system, it's very important to get some insights how would be the next winter. Will it be a wet winter, a dry winter? So the 6 months projections of the climate or forecasting of the climate variables like the rainfall is very, very important for those guys who are managing all the power system in Portugal and the other countries, but we are working in Portugal. And the key point here is that forecasting 6 months ahead of the climate variable is the most difficult one. So we are working with the meteorological agency from Germany that are producing this type of, and are improving this type of forecasting. And what we have done, what we have doing is to incorporate these projections. What does it mean in terms of management of the power system? So EDP is one of our stakeholders, and they are testing different strategies for that. For example, we have also regarding the water consumption for the energy system, we have estimated the water use for Brazil and the Iberian Peninsula, and try to understand what does it mean under future climate change scenarios, and what does it mean in terms of reduction or not, or improvement, or the special distribution of changes in hydropower in the Iberian Peninsula, which for our case is very, very important. I will skip this. So another part that I would like to refer is we are also looking deeper in the spatial scale. For example, it was the first time that this work was done for Portugal, and in terms of Europe, this is also a reference, which is the thermal comfort gaps that we have in the countries. In the common sense, we used to have some cold, and we used to have some very hot environments in our houses, and we have different strategies, and it depends on cultural factors, on financial economic availability, that we have to have your devices, but I have to say that we compute the gap, the space cooling gap in households, only in households, for the current climate, and for the two scenarios, the RCP 4.5 and RCP 8.5. And we can see that today, with the current climate, we have very high gaps in terms of space cooling. Why this is important? Well, this is important in the first place in order to understand where is the energy poverty. And we have done that for all the civil parishes in Portugal. So this is important to understand where is and what is the magnitude of what we call energy gap. Energy gap refers to the lack of access to energy services for thermal comfort, either for the winter or for the summer. Why this is so important? This is important because it is the basis for one of two things very crucial. One is to understand the future needs of energy to tackle this gap. And this has to be assessed in order to understand the future of the energy system. On the other hand, maybe a more intelligent approach is not to think that we will need more energy to tackle these gaps, but to have energy efficiency instruments and policies that could tackle at least a part of this gap. And it could provide good insights for public policies. So, in our cases, and I'm finishing, so I would say that our group contribute a lot, contribute for several NGOs, Sustainable Development Goals, SDGs, but in particular for number 7 that relates to energy, for 11 that relates to climate, and for 13 that relates to cities, to cities and communities. So, thank you very much.